Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek, and this week in the news we have again Terra Luna, about this guy here, Kwon. He's the founder. He initiated the Terra Luna ecosystem. I already reported about the Terra Luna in June 2022, which is this video here. You can watch it. This explains how it collapsed, why it collapsed. In short, the Terra Luna ecosystem, they issued a stablecoin. The stablecoin was an algorithmic stablecoin, and the algorithms were not that sound. That means it didn't work. The stablecoin lost its stability, so it was pegged against the US dollar. It lost the peg, and people sold everything, and then this tokens crashed, or the whole ecosystem crashed, and lots of people lost a lot of money. And he's being prosecuted in South Korea because he's from South Korea, and the government agencies, they're complaining he's not cooperating. On the other hand, he says he is cooperating, so it's an ongoing story here. They also mentioned that they want to put him on a red notice list from Interpol, meaning that he won't be able to travel anymore. I checked this list from Interpol, this red notice website, where you can search for all red notices, for example, from South Korea. It's just one guy, this one here, so Kwon is not on the list yet. This story will for sure continue, and I'll update you on how it continues. Another interesting development is currently happening in Iran, where the citizens are protesting against their leaders, and the leaders or the government, they are trying to censor, or they are censoring WhatsApp, Facebook, and try to control the internet. And here I want to point out that there are many ways on how to get around this. Either use VPN, or in lecture 3 in the spring term, I did a lecture on Tor, since this was during the time where Ukraine was attacked by Russia. Their internet was also censored, and Tor is one example how to circumvent that. There are others. You could use VPNs, and I think it's important to get the information as unfiltered as possible. The next article is about your website and how fast this website loads. This is the following article. How much time do we waste waiting for websites to load? This is a response to the following article that was published already in 2020, that analyzed how fast a website loads. The authors show that the bandwidth is increasing for the end user. This is nice, but the median page load time in seconds stays around the same. So from 5 to 10 seconds, it stays rather quite flat. And this article gets or adds more data to it, and also shows that the median second until entire web page is loaded is around 6 seconds. It was already 6 seconds 2012, then it increased, and now it's around 6 seconds. And he has another interesting statistics. Median seconds until content of the page are visibly populated. This is around 4 seconds, but it didn't change a lot over time. And what he did is he did a graph. It's more on the funny side. So he made some assumptions and showed an estimated number of days waiting for a website to load, and he assumes that you view around 90 web pages per day, and he calculates with roughly 4 seconds that you have to wait for this page. And if you are 35, you wait roughly 36, or into your entire life in browsing the web, you waited 36 days just for the page to be loaded. This is more a critique that this number should actually decrease. I hope in future it will. We have new compression standards that are better and better. We have higher bandwidth. We even have newer protocols like HTTP3, which can reduce the round trip time. So I expect this number in future to go down. I hope it will go down, and we will see if this will happen or not. And exactly that I also wanted to mention, this site has actually a good list why a web page should load quite quickly, because it's about the conversion rate, which increases. So for example, in 2009, they reported that half a second delay in load time resulted in a lower conversion rate, which is actually bad. So you want to have your page load as quickly as possible to get a higher conversion rate. And all these numbers here, they show that page speed matters, and you should have your web page as fast as possible. The next article is about different architectures of WebRTC, or media and conference calls in general. It's not restricted to WebRTC, but can be used with WebRTC. It's this article here. This is an okay article. It has some nice graphs explaining how, for example, SFU, selective forwarding unit, works, and what's the difference between SFU and MCU, multi-point control unit. And just briefly, the difference here is that a participant sends the stream to this central server, and the central server forwards the streams to the other participants. Here at the MCU, you send the stream to this central server. This server then resizes it, puts it into one stream, maybe transcodes it and sends it back to the clients. That means those clients do not need that much calculation. Here, of course, you need more calculations because you get 3 streams. You need to resize it and put it somewhere on your screen. And this is heavy on the CPU, on the end user, not so much for this client here at the server here in the middle. Here it's more heavy on the CPU in the middle and light on the clients. He also mentioned peer-to-peer, that you can also connect to the others as well and send the data there. You can send it directly, but you could also send it indirectly. That's also possible. And he then discussed the pros and the cons. And in the peer-to-peer, he mentioned free of charge. I don't agree with that, because if you use WebRTC in a peer-to-peer setting, you most often need a relay, a so-called turn server. This you need to place somewhere. You might be able to take a free one, but this is typically limited in capacity. So there are also costs involved in that. But it has nice graphs, so it's worth to look at the articles, especially those of you who want to do something with WebRTC. The last article is about GitHub and Tornado Cash, and the article is about how GitHub now unbanned the Tornado Cash repository because they banned those due to pressure from the US governments. And now it's back and will be restored. Tornado Cash is a mixer for the Ethereum blockchain. So there, if you want to send anonymously data, you can use Tornado Cash, and the US governments, they didn't like that, and also they censored the USDC. USDC is a stable coin. It's also cryptocurrency, but it's pegged to the US dollar. And those stable coins, which are from Coinbase, for example, like USDT or USDT, they have a possibility on blacklisting. So authorities may add Ethereum addresses that are not allowed to send those funds further. So this is what they also did. They mentioned here they censored 44 addresses that were interacting with Tornado Cash, and now those USDCs are locked there. But now it's being restored, especially on GitHub, and the GitHub developers working on that can continue to do so. An interesting use case for Tornado Cash was mentioned by Vitalik Buterin. He's the founder of Ethereum, the co-founder of Ethereum, of this blockchain. He's from Russia, but what he mentioned is that he used Tornado Cash to donate funds to Ukraine to protect the financial privacy of the recipients, which actually makes sense. And so there are also legitimate use cases, not only drug money that is being washed, but there are also use cases that actually make sense.